Good morning, students. I am B. Swapna, Associate Professor from Department of Pharmaceutical Chemistry in Mallaradi Vishwavidyapith. Today, my topic is about the isomerism. Isomerism is a topic of compounds having the same molecular formula and they are having different physical and chemical properties. Here, first of all, what is isomerism? Isomerism is a phenomenon in which the compounds have the same molecular formula but different in their arrangement of atoms. These compounds are called isomers. The compounds, and that means isomers of the are the compounds having the same molecular formula but different physical and chemical properties. Why we are studying isomerism? Isomerism plays an important role in organic chemistry, pharmacology, and biochemistry. For example, if we are taking the glucose and fructose, both are having same molecular formula, that is C6H12O6, but they behave differently in the biological system. Glucose is having carbonyl functional group, and fructose is having the keto functional group, but they are having same molecular formula, that is C6H12O6, and they behave differently in the system, behave differently in the biological system. That's why we are studying the isomerism. Now, the types of isomerism. There are two types of isomer. Mainly, there are two types of isomers: isomerism, structural isomerism, and stereoisomerism. Structural isomerism is a molecule with the same molecular formula but different in the connectivity of atoms. They're differently connected to each other. Structural isomerism is of four types: chain isomerism, positional isomerism, functional isomerism, and metamerism and tautomerism. It is of five types. Chain isomerism, they are different in the arrangement in the chain. For example, if we are taking butane and isobutane, both have same molecular formula, that is C4H10, but they are differently arranged. And next is a positional isomerism. Same functional group. They have the same functional group, but the position of functional group is different. For example, if we are taking 1 propanol and 2 propanol, in both 1 propanol and 2 propanol, the molecular formula is same, C3H8O, but the position of alcohol functional, OL means alcohol, the position of OL is different. Here in 1 propanol, the position of OH is at the first position. In 2 propanol, the OH position is at the second position. That's why these are called positional isomerism. These compounds are called positional isomers. Here, they are having same molecular formula, but different in the position of the functional group. Next is a third one is functional group isomerism. Here, the compounds will have different functional group. Here, for example, ethanol and dimethyl ether. Here, ethanol is a alcohol functional group and dimethyl ether is a ether functional group. Both ethanol and dimethyl ether both are having same molecular formula, that is C2H6O. That means they have two carbons, hydrogen 6 and oxygen. But in ethanol, the functional group is a alcohol, and in dimethyl ether, the functional group is a ether. This is a difference, only the difference in the functional. Next is a metamerism. Metamerism means different alkyl groups on either side of the functional group. Different alkyl groups. For example, if we are taking dimethyl ether methyl group, ether is a main functional group, and right side of the ethyl we are having methyl group, and left side also we are having methyl group. That means in metamerism, alkyl, there is a difference in the alkyl groups. This is about the structural isomerism. Overall, structural isomerism, chain isomerism, positional isomerism, functional isomerism, and metamerism. Chain isomerism means difference in the arrangement of chain. In butane, isobutane, position, chain, difference in the chain. Positional isomerism means there is a difference in the position of functional group, and functional group isomerism means there is a difference in the functional group. Metamerism means here the difference in the alkyl groups. This is next one more is there, that is tautomerism. Tautomerism means keto enol tautomerism. There is a difference in the keto group, and keto group is converted to enol functional group. Next is a stereoisomerism. Stereoisomerism, molecules with the same molecular formula, but they are differ in the different spatial arrangement of atoms. For example, it is of two types: geometrical isomerism and optical isomerism. Geometrical isomerism means cis isomerism and trans isomerism. Is a geometrical isomerism again divided into two types, that is cis isomerism, trans isomerism. Here, for example, cis 2-butane, trans 2-butane. Here, cis means the butane means double bond. Here, the cis means the position of methyl groups is at the same side. Trans means it is at the opposite sides. Okay, geometrical isomerism, cis, trans isomerism. Cis means the position of groups at the same side. Trans means the position of any group opposite side is called trans isomerism. Next is the optical isomerism. Optical isomerism is related to the optical activity of the compounds. Here, optical isomerism is a vast subject. Here we are having, in optical isomerism, we are having enantiomers, diastereomers and mesocompounds. Next, this is about the types of isomerism. Here in detail, structural isomerism. Structural isomerism is chain isomerism. Example is butane to methyl propane. Both are having the same molecular formula, that is C4H10. Next is the positional isomers. The difference in the position of atoms. Next, functional isomers, difference in the functional group. And next is a chain isomerism. Here, these are the main examples of chain isomerism, same molecular formula, and both difference in the arrangement of carbon skeleton. Example, butane, isobutane. Here, the key points are same molecular formula and different carbon skeleton. Straight chain isomer. These are also called as straight chain isomers. Next is a positional isomers. Positional isomers having the same molecular formula, but they are having difference in the position of the functional group. For example, if we are taking one propanol, two propanol, in one propanol, OH group is at the first position. In two propanol, OH group is at the second position. Both share the same atoms. Next is the functional isomer. Functional isomers, different functional groups, ethanol and dimethyl ether. This is about the functional isomer. Next, geometrical isomerism. Geometrical isomerism is related to cis and trans isomerism. Cis means having the same both the methyl group. In cis 2-butane, both methyl groups are at the same side. In trans 2-butane, methyl groups at the opposite side. Next is the optical isomerism. In optical isomerism, it is related to the optical activity. These are again divided into enantiomers, diastereomers, and mesocompounds. Optical isomers are molecules that are non-superimposable mirror imaged compounds. These are also called as enantiomers. This is about the isomerism. Isomerism mainly is divided into two types: structural isomerism, stereoisomerism. Structural isomerism is about the chain, positional, functional isomerism. Stereoisomerism is about the geometrical and optical isomerism. This is a brief introduction to the isomerism. This is about the brief introduction to isomerism, and thank you.